For the people who don't know what brain computer interface is or what it could do, could you start by explaining what it is?
So brain computer system where you can control any device or any system using your brain thoughts. So essentially what you're bridging your brain to the computer. So that is called brain computer interface. So with your thought, you can just do anything. You can open up your computer, you can do tasks and you can do, this is how we define brain computer interface.
Right. And what is the process? How do you do that? Because the brain, it's one of the most complicated biological, if I may call it a device. There are a lot of neuroscientists who call this nothing but a interface, a computing interface of sort, because we've got around 70 billion neurons, some 100 trillion synapses, and the way they fire and wire creates all of our perceptions or sight, sound, touch, smell, taste. How do you capture the brain data and how do you interface it with a computer? Could you just simplify this?
So as you tell, yes, our CPU is the brain itself. So everything what happens to has to go through the brain. So suppose somebody is in coma. So what happens is the brain is essentially shut down, but every part is running. So the main part of that is the brain. So as you see in neuroscience, it has grown and it has been growing. So the thing is, we are understanding brain as we know it. So right now, there are many technologies which we can use to measure the brain activity. So what I'm using right now is something called electroencephalography. So that is nothing but we are measuring the voltage spikes happening at the scalp area. So I'm doing something called non-invasive. I'm not working like Neuralink, who is going invasive in the brain. So I'm working on the brain so that we can actually help people and even people who are interested in science fiction. So like controlling home. So I want to do that. So we pick up the scalp voltages from the electrode location. So suppose it can be different locations in the head. It can be occipital region, it can be motor cortex area, it can be frontal area. So we pick up the voltage and then we do the signal processing. So we calculate, we transfer it to the frequency domain. Then we do all the calculations and then we understand what the brain is happening, and then we put the raw data or any process data to the machine learning, and we can actually find the intent. So this is how BCI EEG works.
Would you like to break this up a little bit, because you already defined it as invasive and non-invasive? What do you mean by non-invasive? What are the technologies used for non-invasive and for an invasive?
Okay, invasive is something you open the skull and you put inside the brain. So what you are doing is measuring the neuronal activity. So you're measuring the neuronal activity, what's happening at the neuron level. So with the non-invasive, we are just measuring on the skull. So what happens is you just have to wear something headset like this. So this is something called a Muse. We can just wear it on the skull. So we can just understand what's happening in the frontal area of the brain.
What all kind of data does a simple device like this can pick up from a complicated 70 billion neurons and 80 trillion synapses?
So whatever you think or whatever you do, so there is a neuronal activity happening in the brain. So what you try to do is we try to understand through EEG, through the eyes of EEG. So what we are doing is we're measuring nothing but electrical voltage spikes. So we're measuring the spikes and then we try to understand. It is nothing but we're trying to do this. So it's not the only way, but that is how we have been able to control BCI. The device is nothing but an ADC. So it's analog to digital converter. It just measures the voltage spikes happening. And the thing is you have to have a best ADC which has the best. So it has to provide the true sampling. So it has to provide the true voltages. When you have the true voltages, you can understand brain the real time. So that is the only thing about this device. Then the life changer for me was this. So this is something called Open BCI. So this is one of the very best hardware for some students to learn on. So they have a very good 8-channel device. So from this, I was able to understand about brain-computer interface. So I was able to understand about the electronics part, about how the signal processing happens, how we do the end part. So this is how I actually learned. So the task is like, I put my idea like, so I want to move a car today. So I put my task like, how can I do this? I just write my things and I just start learning. I just Google, understand, learn, and just do these things.
Everything starts with curiosity. If your curiosity bug is ticked, then you will automatically learn. And we have to be lifelong learners. And that's the only thing that will guarantee you success and great life, because the world is changing. Anybody who's rigid, I mean, it's going to be bad news for them. You mentioned something about Open BCI community. lack of awareness. Yes, I do understand India. I mean, there is lack of awareness with technologies like this, and there is no ecosystem support. Investor support is not there. The governmental support is not there because this field is so new and is so in its nascent stage. In another few years, this is going to open up huge economical benefits, because once the investor community understands the potential of what a working brain computer interface can do, I'm sure there'll be a line outside your house of investors and supporters. uh, would you like to explain to my audience what OpenBCI is and the importance of community?
So the OpenBCI is the open source hardware and software. So they have built amazing hardware for EXG. So you can do EMG, ECG, or EEG. So from that, so people can benefit is biomedical students. It can be anyone. It can be just about anyone. So they can understand. They can just measure the voltage happening in the brain, in the muscle area. It can be on the heart area. So you can understand anything. So the very good thing about them is they have open sourced everything. So they have a very good community of the software. They are doing very good things. So what happens is you can do everything. You can learn everything from scratch. It's not like you have to buy something proprietary hardware. You don't have to work with that. So you can't understand what's really happening. So the thing is, as you see, the most of the company actually working on making the headset. So there are not many people who are working on the end part. So how you can use the technology to leverage the technology right now, what's present. So right now what I'm working on is I'm trying to leverage the technology to control smart homes. So that is what I'm actually trying.